Hello everyone, I am Bharati ma'am. In this video, we will master chemical equilibrium in a simple and exam oriented way. Chemical equilibrium made easy for eapcet. So, today we will understand this concept step by step. So, previous year questions I am discussing. So, now try to solve this question along with me. So, now first of all, first question, at 27 degrees, the degree of dissociation of HA in 0.5 molar of its solution is 1%. The concentration of H3O plus A minus and HA at equilibrium or respectively they are asking. So here given information, if you are writing temperature, they given 27 degrees Celsius, they given temperature is the 27 degrees Celsius. Next, acid is a weak acid, that is the HA. Next, molarity the given, concentration the given, molarity terms, that is the 0.5 the given. Next, of its solution means the degree of dissociation. So degree of dissociation we are represented by alpha. So alpha equal to alpha percent is the given. So alpha percentage how much they given? 1% they given. Next, what they given? So now they are asking the H3O plus concentration. H3O plus concentration. Next, they are asking A minus concentration and HA concentration at equilibrium they are asking. So this is the given information. Now coming to the solution. So actually here weak acid is there, that is the HA. So HA, how it is dissociated, that is H plus, means it is dissolved in the water, then it will becomes like a H3O plus and this is the A minus. So now here HA initially is the C concentration, H3O plus concentration is the 0 and A minus concentration is also 0. Now C alpha is dissociated, then it is a C minus C alpha, then remaining is the C minus C alpha. H3O plus, here 1 mole of HA is reacted, then 1 mole of H3O plus, then C alpha is dissociated, means here H3O plus is how much formed means C alpha, and A minus is also C alpha is formed. So now H3O plus concentration equal to C alpha at equilibrium. This is at equilibrium. So HA concentration how much? That is the C minus C alpha. H3O plus concentration C alpha and A minus concentration C alpha. Now alpha value, alpha percentage we know. So what is the alpha? Alpha equal to percentage, if you are taken, then 1 by 100, then it is a 10 power minus 2. So this is the alpha value. Now first calculate the H3O plus concentration. H3O plus concentration, how much that is? C alpha is the concentration formula. This is now C means what is that concentration, that is molarity terms, that is the 0.5 and alpha value is the 10 power minus 2. So totally this value how much will come? 0.005. So this is the H3O plus concentration. And next one, A minus concentration also they are asking. So A minus concentration is also how much? That is the C alpha only, that is the C alpha, same H3O plus concentration like. So C is the concentration how much they given? 0.5 and alpha is the 10 power minus 2, then this total value will be 0.005. So this is the A minus concentration. Now they are asking one more, that is the HA concentration also. So HA concentration remaining at equilibrium how much? That is this is the HA concentration C minus C alpha, C minus C alpha it is. So now C value, that is the molarity only, so 0.5 minus C alpha value how much? That is the 0.005. So now if you subtract the 0.005 from the 0.5, then you will get the 0.495. So this is the HA concentration. So this is the answer for this. So what is the H3O plus concentration? 0.005 and A minus concentration is the 0.005 and this HA concentration is the 0.495. So what is the option? Option number A is the correct answer. So this is the first question. Now coming to the second question. At 300 Kelvin, Kc for the reaction A2B2 gives rise to A2 gas plus B2 gas is 100 mole per liter. What is its Kp at the same temperature? R value also the given. So now coming to the given information. So at 300 Kelvin, so temperature the given 300 Kelvin. Next, Kc for the reaction is 100 mole per liter. So Kc value also the given, that is the 100 mole per liter the given. Next, equation the given the A2B2 gives rise to A2 plus B2. So all are gaseous state only the given. So this is also gas, this is also gas. Now what they're asking? Kp value they're asking. So Kp value they're asking. So keep the question mark, and R value also the given, that is the 0.0821 liter atmosphere per mole into Kelvin. Mole into Kelvin. So this is the R1. So given information this is. Now relation, they given the Kc value, they're asking the Kp value. So what is the relationship between Kp and Kc? Kp equal to Kc into RT power delta n. RT power delta n. So now calculate the, first of all calculate the delta n value. After that substitute all the values. So delta n means what is that? Number of moles of gaseous products minus number of moles of reactant, gaseous reactants. So here products, how many moles? Here A2 is a 1 mole and B2 is also 1 mole. So gaseous products, how many moles? 2. 1 plus 1, this is 1 and this is 1. Products values only we have to take. So 1 plus 1 2 minus reactant moles also, how many? This is 1 mole only, so 1. So 2 minus 1 equal to 1. So delta n value is 1. So now substitute all the values. So Kp equal to Kc into R. Kc value how much they given? That is the 100 mole. So substitute that value also. So Kc value is the 100 mole per liter and R value how much? That is the 0.0821 into temperature, that is the 300 Kelvin. 300 power delta n. Delta n value how much we got? 1. So 1 substitute. So here 100 into 0.0821 into 300. So here two zeros are there, so point will be coming 8 after, so two places after. So 8.21 into 3. So how much? That is the 3. 3 1s are 3, 3 2s are 6, 3 8s are 24. So this total value will be 24.63. So 24.63 into 100. So how much we will get? So here two zeros, here point after two places will be cancelled, then 2463 value. So near value 2460 they given. So this is the